Okay, let's have a look at this then. Fractions. Half of 48, that's what we say. Half is 1 over 2, that's a half. Of is times 48. So how many 2's in 48 goes 24, doesn't it? So you basically cancel top and bottom by 2. 2 goes into 28, 24 times, and the answer is 24. 1/3 of 36, third of is times 36. 3 goes into 36 12 times, so the answer is 12. 1/4 of 32. Well, 4 goes into 32 8 times, so the answer would be 8. So you can cancel top and bottom by a common factor, can't you, when you're multiplying fractions? So that's the notion there. Equivalent fractions, the best way to look at it, of course, is by a pi. There's a half. Now that could be, so that shaded area up here is a half of a pi, so to speak. 2/4, if you do it again, you could divide it into 3/6. With the diagram, we can only show 4/8. There's 1, 2, 3, 4, 5, 6, 7, 8, 4 parts of 8. So you can scale up a fraction by a common factor, multiply by 2, or 3 top and bottom, or 4 top and bottom, or you can scale it back down. So you can divide this by a common factor, say 2 top and bottom, or 4 top and bottom there. So this is the notion of equivalent fractions, and I'm sure you've got a feel for that as well. So like we said, we can go up and down here. A fraction in its lowest form is when there's nothing else to divide out, no other common multiples. So here there's a 5 common top and bottom. 5 goes into 15 3 times. 5 into 25 goes 5. So we can simplify that down to its lowest common fraction of 3/5. Here we can divide by 10 top and bottom, and another 10 top and bottom. We've got 1/20. That's its lowest common simplest form, the fraction in its simplest form. Here they're both even, but so let's divide out to 18, and that would be 63. Now 9 goes into 63 and 9 goes into 18. So if you spot that, that would be a 2. 9 2's are 18, and 9 7's are 63, so it's 2 7's. And that's the fraction in its simplest form. But these other things were the examples of the equivalent fraction. Okay, 4.5. This is well, apparently it's a proper fraction because it's a half. But if you think of the 4, that's 4 plus a half, isn't it? Now you can scale up that as 4 over 1 is the number 4. Scale this up top and bottom by 2, so that would be 8 over 2. 8 halves plus 1 half. And thereby we can now add these common fractions because it's the same type. 8 halves plus another half is 9 halves. This is the fraction that's in proper form, 9 over 2. And this is the fraction reduced to basically a proper fraction part plus a whole number component. So there's the notion of proper fractions and improper fractions. Here 3 and 5/6. We'll need to convert the 3 to sixths, won't we? So 3 plus 5/6. That's 3 over 1, of course. That's what the number 3 is. Scale that up by 6 top and bottom, we get 18 over 6 plus 5/6. 18 and now we've got the same type of fraction, we can add them together. 18 sixths and 5/6 more is 23 sixths. Okay, so that's how you tidy up fractions between proper and improper. Multiply? Well, all you do is if you just think of a simple example, a half of a half, we know that's a quarter. It's just the same as 1 times 1 over 2 times 2 is 4. So if ever you forget what to do with multiplying, just put a simple example up and you'll see what the rule is for multiplying fractions. So you multiply the top, 3 5's are 15, over 4 8's are 32. 15 32's. Here 24 over 20. 3 8's are 24, 4 5's are 20. But there's a 2 common here, so that divide by 2 top and bottom, that'd be 12 over 10. And there's another 2 top and bottom, so you can write down 6/5. And that's the fraction in its lowest form. But if you wanted to, you could actually do, rather than go this way, you could actually spot it straight away, because you can cancel top and bottom by the common multiples. 4 goes into 4 once, 4 goes into 8 twice, 3 2's are 6, and 1 5 is 5. It's up to you. If you spot the common multiples here in the parts of the process, then you can do it straight away. If you don't, then you get this number and you can just divide it out afterwards. So here 4 times 3/5. Well, 4 is 4 over 1. So now we can multiply the top. 4 3s are 12. 1 5 is 5. 12/5. 4 lots of 3/5 is 12/5. Dividing then. Well, if you think 1 over a half, how many halves go into 1? There's 2 halves in 1, aren't there? So this little chappy underneath just swings up to the top. So you get 2 over 1, which is 2. So that's the rule then. The fraction underneath, then the fraction, this part underneath, so to speak, it's underneath here and it's underneath there. Underneath, it swings up to be with the number on top. So that's the rule then as a general principle. And we've just reminded ourselves of that rule by looking at this very simple example. So, okay, so that's that one. So that's that rule. So bear that in mind when we do the more complicated ones. This rule, what happens here when you get a fraction in this form? Well, if you think about a half divided by 2, we know that's a quarter. So can you see what happens? This 2 jumps down to be with that 2 to make 4. And the 1 stays as is. So you get 1/4. So that rule means that the 5 that's in this position just jumps down to be with the 4. We get 16 over 20, which we can tidy up to be 8 over 10. And we can divide by 2, top and bottom, to be 4/5. So then if the number's in this position, it swings up to the top. If it's in this position, it drops down to be on the bottom. So here we've got these two then. Let's apply those rules. And the 12 will swing up to be at the top with the 4. And the 9 will drop down to be with the 5. So that's what we've got. So let's cancel this is just multiplication top and bottom. Let's divide out the common factors. 3 goes into 9 3 times, 3 goes into 12 4 times. So we get 16 over 15, which is 1 1/15, isn't it? Okay, this one. See the 5? It's in this position. It swings up to be with the 6, doesn't it? So we get 6 times 5 over 16. Common. 2 is common. 3 and an 8. 3 5s are 15 over 8, which we can write like that if we want. 15 over 8. So that's how you do the things with one fraction over another fraction. Adding? Well, you can't add fractions easily of this different types. You have to have the same type. So we'll have to convert these to equivalent fractions so that they correspond. So 3 and 5 both go into 15, so we could scale this up by 5 top and bottom. And we could scale this up by 3 top and bottom, couldn't we? So that's the equivalent fraction, 10/9. And this is 10/15. And this would be 12/15. So you get 22 over 15. So that's how you add fractions. The same process, if you see what we did there, we got 22 over 15. Let's do it. There's another method to do this with just a pair of fractions together. And I'll just show you that. So let's see if we get the same answer. With adding fractions, the other simple rule, if you want to use it for a pair of fractions like this, is just cross multiply 10 and 12. So you cross multiply this times this is 10, this times this is 12, over 3 5s of 15, 22 over 15. So let's cross multiply here, 40 plus 42. This is the easiest thing to do usually, cross multiply, it's easy, over 48. That's what we customarily do. That's 82 over 48. Which is 41 over 24, isn't it? Okay, good. Now we can't cross multiply these easily, so we have to revert back to the original, writing them down in equivalent fraction mode, form. So why don't we do that? Let's have a go at these then. Just get rid of this one now while we've done it. Okay, so let's have a look at this one. And then we'll look at this one here afterwards. So let's write them in equivalent fractions. So half, a third, and 4, they all go into 12, don't they? So if we scale this up to 12ths, times by 6 top and bottom, 6 12ths. This one to 12ths, you times by 4 top and bottom, 8/12. And this one you times by 3 top and bottom. 9/12. 14 and 9 is 23 over 12. 23/12. Which if you want to divide out of 12, it would be 1 and 11/12, wouldn't it? If you wanted to write it in proper fraction form. This is improper. Here, 3, 5 and 9. What's the smallest common multiple? What's the smallest number they all go into? 15, 30, 90? 90 they go into, don't they? They all go into 90. What if there's anything less than that? Not sure, so let's do 90. We just need to find something they all go into. So scale this up by 30 top and bottom. 30 over 90. Scale this up by 90 would be 18. 18 threes are 54 over 90. 18 fives are 90. And 10 top and bottom, 20 over 90. So we've got 90ths all the way through. Now we can just add them. 30, 50, 104 over 90. Divide by 2 top and bottom is 52 over 45. Yeah, that's it, 52 over 45. Okay. So that's the other thing. They all went into 45, didn't they? So we could have done 45ths and got the same answer, of course, if we'd have spotted that. Subtracting then, again we use the cross multiply principle here, but we just take into account it's a minus rather than a plus. So 14, 2 sevens, 3 ones, minus 3 over 21. 3 sevens are 21. 14 minus 3 is 11 over 21. Next one, 20 minus 6 threes are 18 over 24. 20 minus 18 is 2 over 24, which is 1 over 12. Okay, that's minus, so we just cross multiplied. Here, because there's 3 of them, we're going to have to get equivalent fractions, aren't we? So let's make a bit of room, and we'll have a go at this one now, these. Let's have a go at these. Okay, 1, 2, 3 and 5 is 15ths, so that's 15ths would, no, 30ths is the smallest, isn't it? 30ths, so it's 15 top and bottom, 15 30ths, 10 top and bottom, 20 30ths, minus, and this 6 top and bottom is 12 30ths. 15 take 12 is 3, plus 20 is 23 30ths. Next one. Okay, we've got 4, 7 and 8. 4, 7 and 8. Awkward. 56 and 4. Yeah, I think 56. It'll have to be, won't it? So 56. So 4 what's a 56? 4 14s? So 3 14s are 42 over 56. That was awkward, that was, because the number's awkward. 8 minus 8 2s are 16 over 56. And 7 3s are 21 over 56. 16 and 21 is 37. 42 take 37 is 5 over 56. So I'm not going to do this example 2 litre juice because it's just a practical example of all the other things we've done. So I might do that again when we do the exercises by way of an introduction to those in question 1.